Right. So before going to the electrochemistry depends on only 4 fundamentals total, right? Enox, red cat. These two animals are pillars for the electrochemistry. ఏంటవి? Enox, red cat. Enox, red cat అంటే ఏంటి? At anode, oxidation takes place. At cathode, reduction is. At anode, oxidation. At cathode, reduction is takes place. This is the 4 pillars, right? 4 pillars for example, big building like electrochemistry, right? So before going to actually why we need to study the electrochemistry, how they are asking the question, what we will discuss in this electrochemistry, right? First, we need to know oxidation and reduction. Oxidation, basic definitions are enough. Oxidation means by oxidation, addition of electron, addition of, right? Loss of hydrogen, loss of electron. They're called as oxidation. Reduction means what? No, removal of oxygen, addition of hydrogen, addition of electrons. Particularly, we'll speak in terms of electrons over here. That is more than enough here in electrochemistry, right? For example, Zn gives rise to Zn2 plus 2 electrons, right? What is this? Yes. For example, Pb4 plus is converting into Pb2 plus. This is oxidation or reduction? Reduction. Addition of 2 electrons, right? So addition of electrons, removal of electrons, first we need to identify. This is the first point which we need to know. And total electrochemistry, we are having 2 types of cells. Electrical energy is converting into chemical energy, and chemical energy is converting into electrical energy. Electrical energy is converting into chemical energy, and chemical energy converting into electrical energy. So let me know what is electrical energy is converting into chemical energy and chemical energy converting into electrical energy in our daily life. Any example? Batteries in car batteries, mobile అంటే మొబైల్ వాడడం లేదు మీరు, but generally we'll use in car batteries. What is electrical energy converted into chemical energy? No. Electrical energy converted into chemical energy means what now? For example, oxygen cylinder is there. Right now, outside lot of oxygen is there. To take one cylinder, just oxygen go to the cylinder and పోతుందా? మరి ఎట్లా పోతుంది? ఆక్సిజన్ ఎలా సెపరేట్ చేస్తాం? ఆక్సిజన్ ఫ్రీగా దొరుకుతుంది కదా, మరి ఎందుకు కొనాలి? హాస్పిటల్ ఆక్సిజన్ బయట దొరుకుతుంది కదా ఫ్రీగానే, మరి ఎందుకు కొనాలి? ఆ గ్యాస్ని పంపిస్తే అయిపోతుంది కదా. అంటే ఎలక్ట్రాలిసిస్ చేస్తాము. ఫర్ ఎగ్జాంపుల్ సోడియం మెటల్ ఉంది. సోడియం అనేది హైలీ రియాక్టివ్, మనకు నేచర్లో దొరకదు, నేచర్లో దొరకదు మనకు అది, రైట్? అదంటే ఆల్ కంబైన్డ్ ఫామ్లో NaCl కానీ Na2CO3 అలా ఫామ్లో దొరుకుతుంది. ప్యూర్ సోడియం కావాలంటే ఏంటి చేస్తాం మనం? ఎలక్ట్రాలిసిస్. సో ఎలక్ట్రాలిసిస్ అంటే ఏంటంటే బై కరెంట్ను వాడి మన కెమికల్ ఎనర్జీ లైక్ ఆక్సిజన్, గ్యాసెస్, హైడ్రోజన్ గ్యాస్, హీలియం గ్యాస్, ఇలాంటి వాటిని మనం ప్రొడ్యూస్ చేస్తాం. ఇక్కడ ఏంటి? కెమికల్స్ను వాడుకొని మనం కరెంట్ ప్రొడ్యూస్ లైక్ కార్ బ్యాటరీస్ లైక్ దట్. These two are very important. This is where called as electrolytic cell. Electrolytic cell. This is electrochemical cell. Electrochemical cell. Electrochemical cell, or we could say the galvanic cell. Galvanic cell, voltaic cell. So దీంట్లో what is the main difference in these two cases? Anode, cathode ఉంటుంది. ఇక్కడ కూడా యానోడ్, క్యాథోడ్ ఉంటుంది. మరి యానోడ్, క్యాథోడ్ జనరల్గా ఏంటంటే రైట్ at both the cases at anode oxidation, cathode reduction is takes place. Both the cases the same thing is happening. At anode here is positive charge, cathode is negative charge. Hello. In this case anode is negative charge, cathode is positive charge. There is a main difference. Okay. While cell construction, electrochemical cell construction, anode will take the positive charge, electrolytic cell. What is exactly electrolytic cell mean? Okay, anode and okay, cathode is right. Imagine anode, cathode. Time into manaki right. At anode, which I told you, which charge? Positive charge. Cathode, negative charge. So I'm taking the fused NaCl. Fused NaCl means what? Na plus and Cl minus only is there, the total mixture. At anode, which reactions are takes place? Right? Anode positive charge. Oxidation. Oxidation means what? Which one is coming? Na plus and Cl minus? Cl minus. Why? Because this negative charge, positive charge. So Cl minus gives rise to Cl2 plus 2 electrons. What is this? Oxidation is takes place. Whereas in this case at cathode, negative charge, right? Na plus electron gives rise to Na. That means chlorine gas and sodium metal is deposited at the cathode. This is nothing but electrolytic cell. Electrolytic cell. Right, write it down. Right. For example, fused, in case of fused means only one. Aqueous NaCl if you are taking, what happens? If I am taking the aqueous NaCl, water plus NaCl. Water exactly happens, what happens, Nana? H plus plus OH minus. Na plus, how it is? Na plus plus Cl minus. Now they are asking this type of questions. At cathode, which gas or which ion is deposited? At anode, which ion is deposited? They are asking the questions like this. So now H plus and Na plus competition is coming here. Which one is discharges first at the anode and cathode? Very, very important info. Yeah, tell me. Here is discharge potential theory is there, Anna. Preferential discharge potential theory. Preferential discharge potential theory. So at one electrode, more than 2 or more ions are present. The ion which is having the lowest discharge potential is discharges first. Okay, oka electrode daggara, right? 2 ions unnappudu, for example, right? 2 ions unnappudu, anode and cathode, right? Write it down, put the heading, preferential discharge potential theory. Write one statement. According to this theory, when 2 or more ions are present at the electrode, the ion with lowest discharge potential, deposits first at that electrode. So we need to know this order, Nana, for anions and cations, both are. So this is one of the important. Write it down. Decreasing order of discharge potential for cations. Decreasing order. Okay, almost. But I am not giving all. Decreasing order. Decreasing order means what? Right. Okay. Yes, sir. For anions, decreasing order for discharging potential for anions. Write it down. SO4. SO4 2 minus NO3 OH minus Cl decreasing order. Potentials, electrode potential based on. But మనం ఎలా గుర్తుపెట్టుకోవాలంటే we can use is by using our logics. At any shortcuts, anything. So previously, what we got, Na plus and H plus. So Na plus is coming here, is H plus is coming here. Which is having the less discharge potential? H plus. So means H plus, right? Undergoes hydrogen gases at cathode. And OH minus Cl minus, obviously Cl minus oxidize, Cl2, write it down. Preferential discharge potential theory. So this preferential discharge potential theory is applicable when we are using the inert electrode. Write it down. When we are using inert electrode. Write it down. Inert electrodes and active electrodes, both are there. Now aqueous NaOH, aqueous HCl, write it down. Aqueous HCl. At anode and cathode reactions, write it down. Aqueous H2SO4, aqueous H2SO4. At anode and cathode, which ions are liberated? That is important. Aqueous Na2SO4. Aqueous Na2SO4. Aqueous CuSO4. Aqueous CuSO4. Aqueous AgNO3. Aqueous AgN. In 4OH minus, what exactly happens? So OH is oxidation, and 4OH minus gives rise to 2H2O plus O2 plus 4 electron. Write it down. This is the oxidized product for OH minus. When the OH is coming, we need to use that. For example, aqueous NaOH is coming. Na plus H plus OH minus, both the cases. Na plus and H plus cases, H plus is coming. H plus plus electron, where at an is at cathode reductionist takes hydrogen gas, 2H plus. At oxidation is takes place at anode, right? The same reaction, 4OH minus gives rise to 2H2O, O2 gives rise to 4 electron. So they'll aqueous NaOH on electrolysis at anode, which gas is liberated? They are asking this type of question. Oxygen or hydrogen, like that they'll ask that. This is one area which we need to, and in all the cases I think you can do, right? Right? Oh. H plus HSO4 minus, or SO4 minus also we can take. I gave you the list, right? 2H plus SO4 2 minus, 2H plus plus SO4 2 minus will take, but it is OH minus is coming, by default we'll go with the OH. It won't come. 2H plus, right? 100% dissociate, strong acid. And when we are using the active electrodes, for example, AgNO3, aqueous AgNO3 at platinum electrode, here is platinum electrode. What exactly happens? Here is Ag plus H plus and NO3 minus OH minus. Let me know. Here is Ag plus is coming, right? In this case, OH minus. This is can act, right, when you are using the inert electrode. inert electrode. When we are using the inert electrode, this is exactly happening. For example, if you are using the active electrode, silver active electrode, Ag, silver active electrode. Active electrode means what? At anode and cathode, only Ag will participate in the reaction. Means what? Ag gives rise to Ag plus electron. This is oxidation at anode. And at cathode, Ag plus electron gives rise to Ag. So these two reactions always takes place when we are using the active electrode. Write it down. When we are using the active electrode at right, this is oxidation, right? At anode, at cathode. By default itself undergoes oxidation as well as reduction. When we are using the active electrode, it is Ag is active electrode. It not be Ag, for example. It could be anything. For example, I can take copper sulfate. Copper undergoes oxidation and CuSO4 copper electrode, copper active electrode. CuSO4 అప్పుడు ఏంటంటే కాపర్ పెట్టినప్పుడు కాపర్ అండర్గోస్ ఆక్సిడేషన్, కాపర్ అండర్గోస్ Cu gives rise to Cu2, right? 2 plus 2 electrons, Cu2. Next area, so which we'll discuss, Faraday's first law. This is important. Faraday's first law, Faraday's second law, both are important. What is Faraday's first law? W directly proportional to Q. So means what? పిండి కొద్ది రొట్టె అంటాం. ఎక్కువ పిండి వేస్తే ఎక్కువ రొట్టెలు వస్తాయి. ఎక్కువ కరెంట్ పాస్ చేస్తే ఎక్కువ అమౌంట్ ఆఫ్ సబ్స్టెన్స్ డిపాజిట్ అవుతుంది. So means the weight of substance which is deposited at the electrode is directly proportional to charge we passed. W is equals to ZQ. What is Q? Q is equals coulombs of electron. Q is equals to I into T nano. W is equals to Z into I into T. What is I? Current in amperes. Time in seconds. Time in seconds. I into T. Electrochemical equivalent. This is Faraday's first law. So Faraday's second law means what? When cells we are connected in a series, we are taking the different electrodes, right? Anode and cathode. Same current if you are passing. For example, see, 3 students are there in front of me. All are, I'm teaching to all same. Will they understand same? No. Based on their capacity, they'll learn. Based on their background, based on their basics, based on their fundamentals and all. Here is also based on, for example, here is iron, in this case somewhat zinc, somewhat hydrogen, whatever it may be depositing. So based on their equivalent weight, W1 by E1 is equals to W2 by E2, W3 by E3, like that use. Okay, write it down. The definitions and all అవసరం లేదు. Well, if you want, you can write the definition. Okay. Done? W1 by E1 equals to W2 by E2. W means what? ZQ, right? we are passing the same current. So means Z1 Q, W1 can I write? W2 means Z2. So Z1 Q by E1 equals to Z2 Q by E2. Q because same current we are passing. So Z1 by E1 is equals to Z2 by E2. From this, E is directly proportional to Z. E is equals to Fz. F means what? Faraday. So here is Z is equals to E by F. What is E equivalent by? So Faraday. What is Faraday? 1 Faraday. 1 Faraday is equals to what? Charge of 1 mole of electrons. Write it down. Charge of 1 mole of electrons. 1 mole of electrons. Charge of 1 mole of electrons. 1 mole means what? 6.023 into 10 to the power of 23 into charge 1.602 into 10 to the power of minus 90. So if we calculate, we'll get 96,500 coulombs. Means 1 Faraday is nothing but charge of 1 mole of electrons. That is very important, or 96,500 coulombs. So Z is equals to what we can write? E by 96,500. Right? So W is equals in place of Z, E by 96,500 into I into, this is the two formulas, this one and that one, to calculate the numericals. Okay. Here is any questions if they are asking directly by using this formula. Otherwise, we'll do like this. For example, one sodium is there. Sodium Na plus electron is raised to Na. Here is 1 mole if you are taking, right? 1 mole of electrons, right? 1 mole of electrons, how much sodium is depositing? It is 23 grams. Yes or no? 1 mole nothing but what? 1 Faraday. 1 Faraday is, if you are using how much? How many grams? 23 grams or 96,500 coulombs if I am using 23 grams. Coulombs. Coulombs means what? Q into Q is equals to I into T. Coulombs. Q we will take in the coulombs. This is important. Right? For example, Mg2 plus 2 electrons is raised to Mg. If I am using the 2 mole of electrons, 2 mole of electrons, how many? 24 grams. If I am using 1 mole, right, 2 Faradays, 24 grams. 1 Faraday if I am using 12 grams. So 2 into 96,500 coulombs. Like that we can solve the question. Right? AlCl3, same. Al3 plus 3 electrons gives rise to Al. 3 moles of electrons, 27 grams. 1 mole if you are using, right, 9. Right? 3 Faradays, 27. 1 Faraday, 9 grams. Right? This is the way which we can solve the numericals. Write a question, I'll give you a question. Write a question. One model question only will do. A solution of copper sulfate, a solution of copper sulfate is electrolyzed for 10 minutes. Solution of copper sulfate is electrolyzed for 10 minutes. 10 minutes with a current of 1.5 amperes. A current of 1.5 amperes. What is the mass of copper deposited at the cathode? What is the mass of copper? What is the mass of copper deposited at the electrode? Come on, do it. Right, Cu2 plus S2 electrons gives rise to U. Copper atomic weight is how much? 63.5. So 2 moles of electrons, right? 2 nothing but 2 into 96,500 coulombs now. 63.5 grams. Right? Here is 10 minutes means what? Q is equals to I into T. I is how much? 1.5 into time. 10 into 60. Because we need to take in seconds. So this is how much? 900, right? 900 coulombs. So this much of coulomb 63.5, 900 coulombs. How much? Simple. But no need to use that formula. If you want, you can use that formula also. W is equals to, so how much? Huh? E. E means what? 63.5 by 2. This is E by 96,500 to I. 1.5 into 60 into 10. Like that also we can do. Both are same. This is a model you can solve. This model is very famous. Otherwise, you can use that also. Equivalent weight. Equivalent weight by means atom molecular weight by valency. Molecular weight by valency, nothing but equivalent weight. Okay. This is one area which we need to solve. So then the physics part which is coming, like resistance, conductance, specific resistance, molar conductance, equivalent conductance. So I think that is, can you manage or shall I explain? Correct formula based on technical. Right, so we'll continue in the next class.